So welcome back to Jumanji, everybody. So today we're gonna be numbering atoms and figuring out what bonds are formed, what bonds are broken, right? Because in order to write a reaction mechanism, even before you understand acid, base, elimination, nucleophile, whatever, right? If you can't identify what bonds are formed, what bonds are broken, you're pretty much lost, right? The goal is to number your heavy atoms in your starting materials, right? Your non-hydrogen heavy atoms. You can number them any way you want because this is for you, right? But in this instance, they already numbered the starting material for us. And they number it like this. And I circled the number to make it easier to follow. I have the new blackboard on my Christmas list, don't worry about it. So all right, so we're not numbering hydrogen atoms, and we're only looking for the sigma bonds formed and broken. Pi bonds are not relevant here because they naturally follow the path of the sigma bonds, right? So here they left out certain atoms because they didn't really change in the product, so they just don't waste any time worrying about that. You can start here, recognize these two because they're still the same, and in between is number one, right? So it's safe to say number one is still right here, right? From there we know number one is attached to this number two oxygen, right? This is number two. Now we have a new bond between number two and something, right? So we're not sure yet. Let's just jump over and go back to what we do know. We know this is a number 8, right? And we know that number 8 is connected to number 7, right? So number 8, number 7, right? 7 is connected to 6. 6 is connected to 4, right? Which makes sense because look, it's still under the carbonyl carbon right here. 4 is attached to 5, right? And all we're left now is number 3. And so now it's just a matter of figuring out which bonds were formed, which bonds are broken by just matching and following the pattern. We have a number 2 now, right? That was by itself before. Now we have it attached to number 4, right? So you have your O2 now forming a bond, right, with your C4. But we also have your C4 to your O3 broken, right? And now you have your O3 taken up with your C6, right? And your O3 broke from your C4 to get with your C6. So broken is your O3 from your C4, broken, right? And one more bond form here. We have your carbon 1 now attached to your carbon 7, and that triple bond turned into a pi bond, right? So you have your C1 to your C7. So by doing this, right, you can see what atoms, what bonds are participating in the reaction mechanism, right? And trust me, I know how many times I say the word right. I'm working on it.